All right, in this video, we are taking a look at a new equation. It's an equation that is in what's called slope-intercept form. It's y equals mx plus b. You need to be very familiar with this equation and be very familiar with this phrase slope-intercept form. Now, let me give you some idea of what y equals mxb is and what some things stand for. First and foremost, the m. Okay, the m is the slope. Okay, and we have talked about slope in this class. Slope is the rise over run, or it's the change in y over the change in x. We call that the slope. It's the rate of change. Okay, and then the b in this slope-intercept form is called the y-intercept. Okay, and the y-intercept is when x is 0, then the y-intercept, or the y, is the b. So when we're looking on a graph and we have the x is 0, then whatever the y is, it's the b in this formula. That's the y-intercept, okay? And we're going to look at some examples of this. So first of all, let's look here. This example, we have an equation that is graphed. Here's the equation y equals 2x minus 3. And it is currently in slope-intercept form because here you have the slope, y equals mx, and then plus b. The b happens to be a minus 3. So this line is in slope-intercept form. Remember, the slope is from point to point. We have a rise and a run, or a change in y over a change in x. In this one, very specifically, we have to go up 2 units, and then we have to go to the right 1 unit. So that is a slope of 2 over 1, which we know equals 2. So remember the formula, y equals mx plus b. We just replace the m with the 2, the slope. So we have y equals 2x plus, and then the b. The b is right here, this point that is on the y-intercept. Because remember, 0, the x value is 0. We don't go right or left. It's 0, and then the next number down, or the point, is down at -3. So this ordered pair is at 0, -3. So then this -3 becomes the b. So we found the slope of 2 from rise over run, and then we see this point right here at -3. So we just write y equals mx plus b. So it's going to be y equals 2x minus 3, which was the equation up here. All right. Now, let's take a look at a real-world application here. This says that the graph, which is over here, relates temperature y, which is in degrees of Fahrenheit, to temperature x, which is in degrees of Celsius. Find the slope and y-intercept. Write an equation of the line. What is the mean temperature of Earth in degrees Fahrenheit? Okay, so really all we're looking for is to try to understand the idea of slope-intercept. So you see a line here. Okay, you'll notice that you have 2 points. One of them says 0.32. In this specific situation, it's saying when the temperature is 0 degrees in Fahrenheit, then it's 32 degrees in Celsius. Now, y'all will recognize 32 degrees Celsius. That's where we understand is freezing temperature, okay? When water freezes 32 degrees Celsius, well, that's 0 degrees Fahrenheit. Here's another point. 30 degrees Fahrenheit is 86 degrees Celsius. Well, if these 2 points are graphed, you can simply figure out the change in y over the change in x. Now, sometimes it's not easy to just count up and over on a graph for the rise and the run, but you can find the change in y right here, the change in y over the change in x. So we have 86 minus 32. If we were to have worked that out, it's 86 minus 32. That would be the change in y. And 86 minus 32 is 54. And then we have 30 minus 0, which is real simple. If we just did 30 minus 0, 30 minus 0 represents the change in x. So you see we have it right here, it's 30. So 54 over 30, so we would simplify that to slope. This has a slope of 9/5, okay? Now that is an improper fraction, but we could just keep it as a fraction. So in our formula, the equation is y equals 9/5 x, okay? And then plus 32. Remember, this is the b, or the y-intercept. Here's the y-intercept right here. When x is 0, the y is at 32, so we just plug that in. Now, this 9/5 represents the slope, and it's called the coefficient of x. Well, in this real-world situation, that 9/5 represents the fraction that you use to convert the temperature of Celsius. You multiply times 9/5, then you add 32 degrees, and you get the temperature, okay? So, or the temperature in Y, which is in Fahrenheit. Now, I just gave you this to kind of give you a real-world example, but we're going to take a look at some practice problems using this equation, or slope-intercept form. So first and foremost, here's an example. I want you to graph the following equation. So if you're given this equation, y equals negative 3x plus 2, okay? Well, this equation is in slope-intercept form. So we have the slope is negative 3. Now we could call that negative 3 over 1 because remember it's rise over 1. So negative 3 over 1. And then, of course, we have the y-intercept. So we're going to start our graph. If we're asked to graph this equation and it's in y equals mx plus b form, we're going to start our graph at the y-intercept. Remember, the y-intercept means that x is 0, and then y is this number here, which is 2. So we would say 0, 2. Let me go ahead and write that down. This means that our y-intercept is at 0, 2. Okay? This is the y-intercept. So if we come up here and we put a point at 0, 2, we can start our graph at 0, 2. Then we just apply the slope. Now this has a slope of negative 3. So it's negative 3 over 1. So we could say down 3 units. So we go 1, 2, 3. And then we would go to the right 1 unit because it's negative 3 over 1 as a fraction. Negative 3 over 1. So we will go down 3, 1, 2, 3, and to the right 1, and we will put a point right here. So I'm going to go ahead and put that point right there. Now we could do it again. Negative 3 over 1. So we can go down 3, 1, 2, 3, and over 1. And put the point again. Okay? So let's put one more point here. Okay? Now again, if your slope is negative 3 over 1, we could also say, we could also make the rise a positive 3 and the run of negative 1. Because all of these points go up 1, 2, 3, and to the left 1. Positive 3 and to the left 1. Positive 3, 1, 2, 3, and to the left 1. And we could put a point right here. But what's most important to identify is that because this is a negative slope, then it's traveling from left to right, it's traveling downhill, and then we could just draw a line through this. This is not the best line, but you get the point. Actually, I could draw a better line. So you can see with this line that it goes through all of these points. And again, remember this point here is at 0, 2. That's the y-intercept, or y equals mx plus b, okay? Let me go and write that down one more time. That's y equals mx plus b. All right. All right, this example says to write the equation of the line from the graph. Okay, so here's the line. Notice we have 2 points that are highlighted for us. Let's go ahead and write down what those points are. Remember, we're looking for the x and the y. So this one is over 3 and up 6. And then this point would be at -6 and then 0. All right, so let's go ahead and write those down. We need to know what those are. So that's 3, 6. And then we have one at -6, 0. Okay, now because this is already graphed, we could find the slope. Okay, we could use the slope formula, or we could count our rise and our run. So let's go. We go up 1, 2, and we go over, well, if we went from point to point, we'd have to go up 1, 2, 3, 4, 5, 6, and then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but you'll notice there's some more points within here. So here's one actually right here. Here's another one, and here's another one. So really we're going up 1, 2, 3, or we're going up 1, 2, and over 1, 2, 3. So really we have a slope of 2/3. So we could just say our slope equals 2/3. Okay. Now I found that by using my points and looking at a rise over run. I could just do the change in y. Remember the change in y over the change in x. Let me go ahead and write that down. So we have the change in y over the change in x. That's where we do x2 minus x1. So we could say 6 minus 0. So that would be 6 minus 0, which equals 6, over the change in x, which would be 3 minus -6, which would be 3 plus 6. I'll go ahead and write that down. So that would be 3 minus -6, which becomes 3 plus 6, and that equals 9. And there's your slope, 6/9. And 6/9 simplifies to 2/3. So we already know our slope. Remember, we're writing this in y equals mx plus b form. So we know what our m is. Our m equals 2/3. So we could write this as y equals 2/3 x. Now we just need to know what the plus b is. Well, remember the plus b is called the y-intercept. That's where the graph crosses the y-axis because the x is 0. We don't go right or left. It's at 0, 1, 2, 3, 4. Right here you can see a point at 0, 4. And that represents the y-intercept. So then we would just write plus 4. So that is our equation for this line. Y equals 2/3 x plus 4. All right, that is how you use y equals mx plus b, and that will be our first video